Okay, I guess good morning. I'm going to try to change the microphone position. Okay, let's see. Trying to calibrate the volume properly. That might be too much. Yeah, that should be it. I want to try this position of the microphone to see if I can see the keyboard better. But yeah, good morning everybody. Let's make sure this still works. Day 1, day 2, yes. Here we have 4 stars collected. So yeah, I don't know. The idea is to have a look day 3, maybe day 4, and keep continuing this. Okay, everything seems good. I don't know. How is everybody doing? So, let's see. So I did before, if you didn't recall or you weren't here, I did in another stream day 1 and day 2. And now we'll be doing day 3, which is empty. And we have always sample input and input. Okay, so sample input, I'm not going to read it yet. Let's complete this first before I forget. I mean, the microphone is better that way. Okay, get the puzzle input. Paste. So yeah, let's see if we can make this program work. Let's see. Day 3, the rucksack reorganization. One elf has the important job of loading all of the rucksacks with supplies for the jungle journey. And we have a link to rucksacks. This is just a uncommon, backpack. I just waked up not long ago. Let's continue. So, yeah, one elf has the important job of loading all the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packaging instructions, so a few items now need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go exactly in one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. I mean, how bad is the luck you have to do exactly the same failure every single time? The elves have made a list of all the items currently in each rucksack, your puzzle input, but they need your help finding the errors. Every item is identified by a single lowercase or uppercase letter, that is, lowercase a and uppercase A refer to different type of items. The list of items for each rucksack is given as characters, all on a single line. A given rucksack always has the same number of items in each of its 2 compartments. So the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. For example, suppose you have the following list of contents from 6 rucksacks. Yeah, here comes the garble thing. The first rucksack contains the items, which means the first compartment contains the items these. So like the first half, that's the first container. While the second compartment contains the items those, which is the second half. The only item that appears in both compartments is lowercase p. So yeah, now we explain for that. To help prioritize the item rearrangement, which this is totally. Every item can be converted to a priority. Lowercase item types A through Z have priorities 1 to 26. Uppercase items through A through Z in uppercase 27 to 52. For example, priority of the item type that appears in both compartments of the rucksack is 16 for P, 38 for uppercase L, 42 for uppercase P, 22 for lowercase v, 20 for lowercase t, and 19 for lowercase s. The sum of those is 157. Find the item type that appears in both compartments of its rucksack. What is the sum of the priorities of those item types? Okay. Not bad. Here it comes. So let's see, what are the tasks? We need to separate by lines, and then we need to split the line in half. We'll do contents, let's split by new line. And then for each line, is this proper English? Rucksacks is yes. Whatever, just call like into vec. Semicolon. We're going to put the rucksacks over here. Actually, I need to collect. Let's do just map it. Let's do one at a time. The end. And let's use the debug mode, and now the map. What I want to do here is basically split it in half. Let's just use a function. It's going to be simpler, I guess. This returns two full strings. Does it? I don't think so. I think we can just return the references, but it shouldn't be that hard to return the references. Yeah, so far that seems to be building. Okay. So it lacks the function signature, which is part of the thing. So, okay. So there is the len. And now we could use len divided by 2, which would be that, and then that's up to L divided by 2. And that's dot dot. This is not Python. Okay, why you don't like that? See the values of type str. Consider borrow. Yes, of course. That goes borrow. That's the problem. And then we return left, right. We should also ignore empty lines just in case. Yeah, now it's divided. Okay, so one task is done. Next task. So we need to know which item types are in each, and we need to join them. So for that, and the hash set. This returns, this inputs and a string, returns a hash set of type string owned. Want to own that. You don't like that. But you don't like that because I'm not returning it, right? I mean, do you complain because of that? No. Oh, okay, because I'm not returning it. That's fine. So, actually that will be char. So x.chars, that's an iterator. Can I collect into, I don't know. I don't know, this feels weird. I do? Can I just, wow, this feels like magic. Yeah, semicolon, yes. Now we want to map, but this will need as a function now. So we'll have xy, and we will do item types x, item types y. Yes, it works. Fantastic. So now we only need intersection of those. Should be intersection. Yeah, here it is. Intersection of AB collect. This is a tuple of two hash set chars. Can we do this? And already do that. It's not blaming me in that point. I can? Cannot be built from iterator over elements of type char, because I'm still... Accepts two chars, yet... Yeah, it doesn't tell me, but it returns intersection. I think it returns a reference. Blames me, it doesn't want me to do that. Yeah, whatever. whatever. Hey, my headphones, the 80 ohms version, by the way, hello Antino 4. Yes, I think so. Let me check. Yeah, I don't know if you can see. Yes, they are the 80 ohms version, yes. So you know about those. I forgot the name. Why? What? Yeah, they work very well. Yes, I like how they sound.
I got you, boy.
I am confused. So I did this map and I was using contents. Now I add this map and I'm not using contents anymore. I'm not printing anything. Oh, stupid. Was doing day 4. It's day 3. So yeah, the headphones are really nice. Have them from for a while. They are cheap. They are very cheap for the quality. Very sturdy, very lightweight. I love them. So yeah, I have the solution here. And to be fair, there is only one option. And because there is only one option, you know what? I don't need to collect into another hash map. I can... We are going too fast. We are going too fast. We are going too fast. Because I'm not sure if I want that. So if I do only one for intersection. Let's make another function. Let's input just X and do that returns collects. I'm just going to comment it out and do it in here. It's not first. Do I have next? Okay, first, next, whatever. Next unwrap. And we will get the characters. I started the last stream when I was doing this into doing all by functional approach, filtering, mapping, and so on, and following this approach and resolving this in a very short amount of time and very short amount of lines. Yeah, so the only thing that's remaining is transforming that into priorities. Things with cable work well, but there is always the cable pulling from you. I hate that. To priority. C as a chair, returns an I64, because I don't care about sizes. And now I could do to I64. Okay. Uppercase is a C is uppercase. Should return a boolean, yes. And now this one should be to lowercase? No, to uppercase. Ah, you don't want that? And what is your problem? Once an iterator they use the uppercase mapping of this chart. Yes. Okay. Yes, that's... Yeah, we are not working with UTF here. And A is A as I64. Position is AC minus A plus 1. That will give me for A, will give me position 1. And then if uppercase, we return position plus 26, else position. Okay, you wanted lowercase. Lowercase, I don't care. So now we can do map to priority. Compiles 1638 42. Okay. Sixteen 38 42 22 20 and 19. That checks out. That checks out. Okay. Now can I just do a sum? Good. I wonder, can I iterate it double like that? You don't like that? No, you don't like that because you need to know what is the return value, the return type. Now you need it to be mutable, maybe? No, use of move value. Yeah, 157. Now let's change it to the real input. Now we can comment out this thing if we want. Seven five nine seven. Okay, got 1 gold star. That was nice. So, part 2. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group badge is item type B, then all 3 elves will have item type B somewhere in their rucksack, and most 2 of the elves will be carrying any other item type. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have different badge item type. So, in the above example, the first group rucksacks are the first 3 lines. Yeah, okay, so we have 3 lines, that's one group. And the second group rucksacks are the next 3 lines. Those 3. In the first group, the only item type that appears in all 3 rucksacks is the lowercase r, must be the badges. Second group, that must be set, yes. That is because lowercase r here is the only one common across them, and Z same is common here, but they can also be duplicated sometimes. Sometimes you can get more than one Z or more than one R. Priorities for these items may still found, organize the sticker, and then do the sum. So basically, we are going to split by chunks of 3. Then do the intersections between those 3. So this is a 3-way intersection. And then the result, we feed it by converting into priority, and then we sum priorities. Easy peasy. So let's see, let's cheat a bit and see the environment, what I did the last time. Exactly. And I'm going to convert that into a function. And now contents, that is just a string. So now it does nothing, minus, sorry, dash 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 1. That calls the first part. And we have here part 2. Okay. Part 2 right now is going to do the same. That's going to speed a lot right now. Sorry, that is going to speed a lot. We can do also if I want to do maybe Rust there is clap. Those are the samples. I'm not sure how recent is that. Dependencies. Oh, it is recent. Oh, okay. Someone is maintaining the documentation, the examples and everything. Nice. Want something like that? Talks and examples. Yeah. I just want yes, I will fix you soon. The ref parser, there is okay. Author version about I don't need anything of that. Short, long. Will be part U8 Problem to execute. I think I can do default. No. Default value T. Oh yeah, that works. Okay, that will be 2. We'll be putting the default as 2, and then sample. It's bool. The default for a boolean is false, and now so now okay, and now this is it's building club. There is one mistake because sample input is the bottom one. So this is false, this is true. Yeah, so I can use P1 for part 1, P2 for part 2. S for sample input part 1. Yeah. Okay, that is good. I could also use the bug and then we can just pass args. That will be fine. This way there is less commented stuff and a bit more powerful. Let's leave the auto formatter. So now I can execute part 2, doesn't debug, and do -d, and does the debug. Nice! Nice. Okay, so it needs to be splitted in chunks. So first I'm going to filter empty lines, yes. No splitting half. No that. And this is going to be different. So okay, don't. So I need a vector for that. Do I need a vector? Chain, next chunk, right chunks. What is this? Chunks do not overlap. Ah, I don't need to go to a vector. And you know, because of the type. Goes into an array, so that will be str3. You don't like me. I can understand. No, that's unstable. That's unstable. Otherwise, it's too fancy. That was too fancy. So yeah, no, okay. Let's collect it into a vector. Chunk size 3. That returns an iterator. Okay. We have our block of 3. Let's put here to do. Yeah, it's not going to like that. Let's debug what it returns. Again, you don't like me. Mutable. True. That looks like an array. Yeah, that is an array. Yes.
I slow the whole world down for you. If you want me to, I'll make it all up to you. If you want me to.
next. So that is an array. So I need a continuous intersection or an intersection of 3.
If you want me to.
Certainly I'm going to need that because the section 3, this is going to be x, and this is oh yeah, because for each item I need to convert the fish to a hash set. That is missing. That is missing. Let's do that first. One step at a time. One step at a time. So map each of those. This gives me an array. So this means that you have x and then in Twitter. You still don't like me. Item types. Spectre reference. Okay. That will return an iterator per type. I don't want that. So let's collect into I can just tell it to collect into a vec. Ah, yeah. Effectively, Intuiter doesn't do anything here. Can print that, yeah. Okay, yes. So I get an array of 3 hash sets for which I will need to put into here. And now I'm not going to worry about variable sizes. I know that I have only 3. And I know that this can explode if we pass in proper data, but not that I'm going to care that much. Yes, of course. You cannot return that. That is correct. AB is going to be hash set char. And now we are going to use this one to do AB to C. And now you don't like that. Because I cannot move it out. Can I just borrow them as it's saying? Yes, I can borrow them. It's only reading. So we do this, we map by that. Fantastic. What's wrong now? Section char. Type mismatch in function arguments. Yeah, I actually want to return a map of characters. Expected function signature of vec of hasset char. On the signature of function that expects or just no, it's an iterator. Why? Suspecting a vector. Why is suspecting a vector? This is a char. Oh no. That is because this returns a vector and this is expecting a vector and it's expecting to consume the whole thing. Okay. We get R and Z. R and Z. Yeah. Now we do to priority. No, semicolon, semicolon. And 52. 52, sum is 70. Okay, remove the sample into the bag. Let's go for the full thing. 2607. Doesn't need to be mutable. Okay. So far so good. 2607. Okay. Good. So another thing done. The microphone in this position is nice. So day 4, I guess. This is the sample data, puzzle input, come clean up. Okay, so I'm going first to adapt this. So it looks like a simpler version of this. Open to the side. Okay. We have parser. One. I mean, even though you didn't put. That is interesting. Okay, I'm going to underscore those. I don't want the warning, because I want to copy it over. So copy source day 4 into source day 5. Does that look okay? Yes. Six, 7, 8.
Looking now, don't you know it's the real?
I'm quite happy with that. Lag parsing.
Looking now, don't you know it's the real?
Cargo Tomel. Up. 5, 6, 7, 8. 5, 6, 6, 7, 7, 8, 8.
Looking now, don't you know it's the real?
Yeah.
Looking now, don't you know it's the real?
We are on day 4. Okay. Inputs. Okay, this is not the sample data. This is the sample data. Sample input. That. Always end with a new line. Puzzle input. Okay, let's make sure we are resilient day 4 with sample input. Well, I'm back, mostly. I'll look into this problem in a few minutes. But yeah. Okay. I think I'm ready. Yeah, let's go. Day number 4. Oh, come on, my English. Just had food. The camp cleanup. So, space needs to be cleared before the last supplies can be unloaded from the ships. And so, several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number. Each elf is assigned with a range of section IDs. However, as some of the elves compare the section assignments with each other, they quickly notice that many assignments overlap. To try to quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of the section assignments for each pair, which is my puzzle input. For example, consider the following list of section assignment pairs: 2 to 4, 6 to 8, 2 to 3, 4 to 5, yeah. For the first few pairs, the list means within the first pair of elves, the first elf assigns sections 2 to 4, while second elf assigns 6 to 8. Elves in the second pair were assigned 2 sections. Yeah, this sample list uses single-digit section IDs to make it easier to draw. Your actual list might contain larger numbers. Visually, these pair section assignments look like this. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2 to 8 fully contains 3 to 7, and 6 to 6 fully contained by 4 to 6. In pair where one assignment fully contains the other, one elf in the pair will be exclusively cleaning sections their parent will be already cleaning. So this seems like the most in need of reconsideration. In this example, there are 2 such pairs. How many assignment pairs one range fully contain the other? I would say that this is easy peasy. So, step number 1 is parsing this input. So let's go for parsing the input, because the input has do something like that so we can see it. Has comma separated, then dash separated. So The assignments are contents split by new line. Then for each line X, whatever, we are going to split again by comma. But then within each comma section there are two ranges. So let's map again. And let's just split by comma. So this needs to be collected into a vector. And now I have a freaking mess here. This is probably the sad part of mapping too much. Because now this map here needs to be collected into another vec. Oh, those makes the semicolon. Oh, okay. I will fixing that for each one. Okay. Anyway. Yeah, I'm going to use these arguments. And as usual, I need to filter the empty lines. Did I just stop on the comma? No. We need to go further. We need to split by the dash as well. So, map again. Z. Z split by dash. Now, the result is a number. So map it. And that will go to a nice 64. Unwrap. Collect into vec again. Bingo. There is something weird. I see an array of an array. Am I doing something stupid? Yes, I split it by comma twice. So let's do dash here. Remove this and this. Let's bring them up. Yes. Okay, that makes more sense. That makes more sense. So there are pairs. Those are pairs. Instead of collecting into vec, I would like to collect into a struct pair or something. Debug, copy, clone, or clone copy, whatever. Pair. Pair A will be a lot of ranges there. Range is I64 everything, so I64 everything, I don't know why do I care. Pair A is a range, pair B is a range. Now I would like to collect that into a range. For that, I remember that some program had already... Should be the second program. From Iterator.
You're my reason to smile, reason to smile, reason to smile, reason to smile.
From Iterator I64 for range. Item is I64. Now yep, that should do. So now I can collect this split into a range.
You're my reason to smile, reason to
Yes. And then the pair can be done exactly the same way.
don't you ever
In this case, the items are range. And this is a pair. And this is A and this is B. And now I can collect into a pair. and we fully parse the structure. Okay. What is next? What is next? We need to know if one overlaps the other. Overlaps. Self returns bool. And then this overlaps if self A from less or equal than self B from and self 2 that's A overlapping B. We need to do actually it's going to be simpler to read if I just overlaps B or B overlaps A. Okay. So now map fire overlaps. Can I just do that? You don't like that. Ah, but you don't like it because it's taking a reference. It's a pity that I cannot do that. Ah. Okay. And we need to count them, right? Yes. This sounds pretty stupid. Yes, because I mean it's a boolean. how to zoom booleans. That is totally fine. So we can map it first. Bool to I64. Why do you complain now? What is your problem? Semicolon. And there are two. There are two such pairs. Okay? We remove the debug, we remove the sample data. We get 494. That's the right answer. Part 2. It seems that there is still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. In our example, the first 2 pairs don't overlap, while the remaining 4 pairs do overlap. Yes. How many they overlap? Yes, so we'll move here to part 2. We can use the sample data again and enable the debug. So that will be a full overlap. Now, for regular overlaps, any overlap, returns bool. Let's put a to do because I don't want it to complain on me. So let's get compute intersection. Let's compute first the intersection. So this is pair where no, that doesn't compare those range where from is self a from max self b from. So we are taking the rightmost from and on 2 we're taking the leftmost, which is min, it's the leftmost 2. I don't know why are you complaining so loudly. Okay. Okay. Now we want the valid range. Because there are invalid range when you do an intersection, there is an invalid range.
There's a million ways to say
A valid range is some that, because 6 is valid, therefore yeah, so it means that self from is less or equal than self to. That is the is valid rationale. So self intersection is valid means that it overlaps, because if the intersection computed is reversed, then it's not a valid intersection. It means that it doesn't intersect. There is a gap. Yeah, I think so. I think so. If I'm correct on this, I just do any overlaps, these like that. Let's do sample data. It doesn't explode. There are 4. Overlap assignment space is 4. Okay. Part 2, 833. That's the right answer. Okay, that was quick. I love this kind of problems. This one for me is easy peasy. So yeah, therefore completed, commit. I'm not sure if I should be doing day 5. Oh, he's doing day 5 at the moment. Yes, this one. I'll give it a thought. I don't know if I should stop streaming or I'll do a bit more. I don't know. What do you think, people on the chat? I want to see day 5 done as well. I'll be right back. Meanwhile, you can think about that. I need to ask if I are going to go outside because the weather is, I don't know. Awful is the word. Usually want to go out at this time, but I mean with this weather, I don't know. Anyway.
Ooh la 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 la, ooh la 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 la, ooh ooh la 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 la, ooh la 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 la.
Okay. I decided to do day number 5. Let me put those semicolons here before I forget. Day number 5. Supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates. But because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. Yeah. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stack of crates and the rearrangement procedure, which is my puzzle input. For example, we have here, so those are the stacks of containers that the crane can go through and the movements of the crane. In this example, there are 3 stacks of crates. Stack 1 contains 2 crates. Crate Z is on the bottom, here, and crate N is on the top. Stack 2 contains 3 crates from bottom to top, M, C, D. Finally, stack 3 contains a single crate, P. Yes. Then the rearrangement procedure is given. In each step of the procedure, a quantity of crates is moved from one stack to a different stack. Yes, in the first step of the above rearrangement procedure, 1 crate is moved from stack 2 to 1. So move 1 crate from 2 to 1. So like get from 2, get 1, and bring it here to 1. So this needs to be moved here, and this is what happens here. In the second step, 3 crates are moved from stack 1 to 3. So move 3 from 1 to 3. So this means that 1 at this state, not in that state, in this state, move 3. So move all 3 from 1 to 3. So this crate goes here, then N on top, then Z on top, and that's what happens here. Crates are moved one at a time, exactly. So that's 1, and then the next one, and then the next one. So it ends below. So the crate D was on top, ends below, and the Z is now on top. Both crates are moved again. Yeah, okay. The elves just need to know which crate will end up on top of each stack. In this example, the top crates are C in stack 1, M in stack 2, yeah, Z, M, and Z. So you get the message Z, M, Z. Okay, so we need to grab the puzzle input. And the main input. So the first thing, is going to be to split it, so to find that and that, and split the header from the data. So let's see, following what all he tends to do is split by dash n, separator. We are on day 5. We are going to do part 1 with sample data. Yes. Yes, so the first part is going to be the instructions. Iterator main. Mutable, because now I'm going to do header is it main next unwrap, and let moves is another one. Then we just print header and we print moves. That should give me a similar result. Yes. Okay, we don't care that much on the moves right now because we need to parse the header. So there is lines? What this thing does? Ah, it's just an iterator. Okay. Collecting into a vec this time because I need to parse the whole thing. I cannot parse streaming it. Let's comment that out for now. Yes. So the last one. Okay. The last one is the stacks. Where are they located? The trick is that this is going to tell me how many stacks there are and what are their positions. And I think I'm going to use I could store this just in a regular vector and parse it as integers, but it's more convenient. It's not better, but it's more convenient to use just the hash map to store it in text and don't care about that. So yeah, Struct header. Stacks is a hash map where we have the key, that is the number, that is just a char, and then how far to the right it is, view size, which position it is. From string that returns self, that passes in a string. By reference, I don't really need the string. We are going to want that as a derive debug clone copy. Oh, it cannot be copied because it has a hash map. It's cloned then. So now that could be printable. And now string lines collect last unwrap that has the stacks now. Stacks text. Now the idea will be to enumerate cannot have more than 9 stacks. I just realized that. So you have more than 9 stacks. We will copy 2 characters. That's not possible. So I can assume that it's only for 1 character. So for P for position, C for char, in stacks txt, or just let's just use that chars enumerate. Maybe this is where the spaces continue. Ignore. Then for the remaining, let's just do B C. Yeah, you hate me so much here because it's unfinished. I know it's unfinished. Stop blaming me. Just run it. Yes, not yet implemented. I don't care. So 1 is in position. Yeah, I mean. Stack 1 position 1, stack 2 position 5, stack 3 position 9. I just need to fit that into the hash map. So And I can just copy paste. That needs to be mutable. Insert. For character position. Comment it out. Now we return header stacks. We print out header. Correct. Correct. Those are the index or position. Okay, we got the position. Okay, moving on. I really like having the microphone this way. It's quite neat. Okay, I think I'll use this more often. In vertical. Can even lower a bit. So next part is reading the top of the stacks. We need to read from the bottom up. And we want some kind of DQ. So stack container is a hash map. Char is the key. DQ of type char. Now let's create the same variable. And we need to, in the same position, we need to just insert for the same key vec dq new stack count. Stack count, yes. Count no content. And we got the 3 stacks empty. Now then we should get so we have the position, we have the maybe we don't need even this one, but meh. So we need to get for line in HVAC I could do. Can I do everything -1? No. That doesn't make any freaking sense. Could do everything except HVAC, len -1. Yes, gets everything. That is correct. That is correct. Now from here I can get... Oh, if I do that I cannot get chars? Those are no. Those are lines. Those are lines. Those are lines. No, stupid. Iter map. I can get chars, and I can get the NTH of P on wrapper default, and then gives me the character, the contents. Okay. Yes. Now, same story. If that is ASCII white space, continue. So I don't want that. And I'm reading from top to bottom. So yeah, wait. We'll need the vector here, I will need to pass it here, and this goes at the end. That needs to be mutable. Then v, it's not, it's insert? No. Push back, push front. I don't remember which one is which, so I'm going just to give it a try. So stack 1 contains n that z. Good. 3sp, and this is dcm. It's pushback. Okay. I mean, I had 50-50 chance. So with that, we have the header properly parsed. We need to parse the moves. So what is a move? What is a move? Move. Movies like amount is 64. 64 is what? From, this is char now, and 2 is char because I'm treating it as identifiers, not numbers. And that's it. Then I will need the from iterator trick from before. No, this is not from iterator. This is the regular implements. So str so we could use regular expressions. We could use regular expressions here or something else, I don't know. Regular expressions should be fine. You know, you have a problem, you go to regular expressions, and now you have 2 problems. Are you telling me there is no regex native inside Rust? It's external. Okay, I will buy it. I mean, in the end, it's not going to be the first time that you will need regex in a... All those problems can be done without regex, of course. Anyway,
I
missing the use. Okay. So we want to capture move space the one-to-many numbers from something that is not a space to something that is not a space. Okay. Remember that this is going to build it every single time. And I'm going for this. Lazy static. I'm hating you so much. 1.40. Tamil. Let's try this. Now periods of text, and then you have get X. Okay. Capture from S. This returns an option captures T. Okay. I mean, it should be managing the errors better, but okay, let's give it a try. Doesn't return anything yet. move 1 from 2 to 2. No. Move 1 from 2 to 1, move 3 to 1, 1 from 1 to 3, move 2. Yeah, that looks about correct. What else? I need to compose it, so this is an amount, so amount I64 parse expect there's a string stars where next must be one character we said, so it's one character, 2, and now we do a move amount from 2 and we return self here. And now we can that looks parsed to me. Lines map by L that, and then that will be a move M, and we can get move M here. Redundant closure, true. And we get the same amount. Okay. That is great. Parsing is done. Now the parsing is done, we need to start and really we don't need a stack position, so let's just kill it. That is just redundant. That looks better. That looks better. Okay, and we will have here fn apply move mute self, because we're not going to mute at self, and we are going to get m as move. That I guess we can. No, we just read. We don't consume. We just read because probably we are going to be iterating through it and we are not going to be able to consume it. Something like that. For now, be all equal. Yeah, that's correct. That's unused. Yeah, it's not really making use of that yet. And yeah, we are reading the moves, but we are not doing anything with them. Now, I need to apply that move. So, for in M amount, self move 1 M from M2. From 0 to M amount. Okay, Fn move 1 is move self from char to char. Perfect. And now we only care about moving 1. So from the stack content, can I do from? I don't think. Consider borrowing. Consider borrowing. Know what? That pop back or front? Front, I think. It's the left. That key from oh, because I want get mod. That gives me mutable reference. What is the error? Ah, I need an unwrap. Thanks. Okay. Let from 2 and is grabbing D. Expect and that will create a huge failure because it's not computing properly. It's creating the failure here. Correct. That is expected. But we grab the container from the top. And now self stack count get mute to push unwrap push front, yes, container. Ok, Okay. Oh, what I do need is the order. Because as I'm storing it in a hash map, I'm storing it without order, so I cannot get those in order, 1, 2, 3. Because it's Z, no, ZMZ, which matches ZMZ, which matches, so the algorithm is correct. But I need to preserve order. So for that I need a vec of char here that I can just pushing the character. Yeah, so I have them here in order, so I can access that in the same order. Okay, now top stacks, we are just reading, and that returns, I mean, technically returns a vec of char, but we could just return a string, why not? So, stop blaming me on that. Remaining things. So, for C in self stack, so we know the key. Self stack count. Get C. I think it's already borrowed. Unwrap. Front. That probably needs an unwrap as well. Let I equals that from item. Come on. Let's be a bit generous here. Do you want to borrow? Yes. And do you want to borrow? Yes. If I borrow there, I don't need to borrow here. Correct. Now, item is a character. I mean, stacks, iter, map, C for this. I don't need to borrow there. This is item, debug item, char. Copy it. I have a full-blown char here. And my guess is that I can just do this. Can you collect into string? You can collect into string. Okay. Okay, so I guess. Okay, we have an unwrap on 91. 61. And it will be this one. So I can, instead of unwrap it, I can filter map. Return some value. This is actually what I'm doing here already. So it filters already the non-values. Yeah. Okay, what are we going to consider the bug here? We're going to consider the bug the middle thing. Considering the bug this, so if args, come on, keyboard, collaborate. Need to collaborate a bit. No. Of course, David, of course. If you debug the whole thing, you don't apply the moves. Therefore, the debug is just this. Is that correct? Yeah, that's correct. Okay. So remove the debug. Okay. Okay, let's remove that. Let's go. That's the right answer. Okay. Okay, as you watch the crane operator expertly reruns the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wave it away. The crane is the Crate Mover 9000. It's the Crate Mover 9001. It's notable for many new and existing features. Air conditioning, leather seats, extra cup holder, and the ability to pick up and move multiple crates at once. Again, okay, so it's the same problem, it's just that when they move at once, they stay in the same order. Yeah, I should have been seeing this coming. I've seen that coming, come on. So, let's see. Because the mechanics is the same. So we do P2 sample data in the bag. Of course, it's empty. Of course, it is empty. We're not going to go for the exactly same code. The difference is going to be that we're going to apply the move for the Mover 9001. That's the difference. This doesn't do one by one. I need to pop 3. I need to pop an amount. I need to pop them in the same order. So from container is self, stack container get mute. There is a get many mute. Is this... yes. Doesn't seem to be... doesn't say that it's unstable or anything. Returns an array of length n with the result of its query. Okay. Many mute. And you ask for both. Okay. Please, pretty please. Borrow maybe, I guess. Yes. Now. Yeah, it is unstable. I should have guessed. I mean, I was looking into the library. Yeah, the problem is that I need to finish first with one before starting on the other. That's the only problem. Yeah. Please don't drop that. Up front. I need to grab them. Yes. So stack is a vec. Stack push this. I bet you don't need a type. You need to be mutable, but you don't need a type. I mean, option char. No. Unwrap that. Unwrap that. Now this is a vec of char. Then I need to push them in reverse order. I could just use a vecdq new and do a push front, so it's one that I grab is always on the top or that stack. Now drop from CT please, because I need to grab the other one. I don't want to drop. Maybe I don't need it. Maybe I don't need to drop. I can do... I have the suspicion that I will hit the barrow checker here. Or maybe the barrow checker has been better lately. I'm not going to debug that. MCD is the result. MCD. Bets are that this thing is working now. So I'm going to take my bet that this works. That's the right answer. Okay. With that, I am done. Happy with that. Okay. Success, I guess. Apply a move 9001. Okay. There is just one line difference between one implementation and the other, actually. And just a few lines of code here, so I mean, I would call that success. The code was easy to expand. Good. So yeah, that's going to be all for today. Like 12 p.m. I mean, it's almost lunchtime here. So yeah.
I got you, boy.
Another day I will do day 6.
I got you, boy.
Which looks interesting. Looks interesting. Anyway, that's all for today. Thanks everyone for joining, coming in. And yeah. Let me see if there is anyone streaming right now that might be good doing a raid or something. I don't think so, but no, there is. Oh, there is Kunos Stefano. Why not? Raid. Let's prepare the raid for Kunos Stefano. I don't know what he's doing, but he's doing something on coding on Rust. So, well, see you there.